The grandfather of quantum, Richard Feynman, he famously said, if you think you understand quantum mechanics, you didn't understand anything.
Right. So let's go back to quantum technologies. I met so many amazing people today, and I'm learning so much about quantum technology. Now I'm here with Sergio. Sergio, please tell us a little bit about who you are and why you are here at this conference.
So my name is Sergio. Thank you very much for having me here today. I am the managing director at Moody's Analytics of AI and quantum computing. So since I lead the quantum computing team, this is the perfect spot to meet with vendors, hardware providers, but also with other people in the industry who are trying to get solutions like everyone else in this industry.
And my first question is something that I'm already knowing the answer to, but do you have real-life applications of quantum technologies yet?
We have real-life use cases.
Yeah.
We have plenty of places where we are trying to implement quantum solutions. None of them has advantage today.
Yeah.
But that doesn't mean you cannot start or you should not start today. Your way into quantum takes quite some time. It's not something definitely easy to learn, unfortunately. Yeah. So, like Moody's, we work with many companies in the financial industry, right? When we talk to them, we realize that none of them, only a few of them are actually playing. The names are out there, but the vast majority are not even considering it. So you need to start today upskilling your team, identifying the data sets, identifying the use cases, where it's going to be useful for you. So whenever there's quantum advantage for one specific case, you don't lose your competitive advantage in there.
I personally am a regular software engineer with classical computers. How would you describe like the future transition from classical computer to quantum computer use cases? Is there like a ongoing transition, or will there be a cut where we will stop using regular computers for use cases and simply switch to quantum computers?
So I think there's two ways of answering that question. As a software engineer, do you worry about the transistors in the chip? Probably not, right?
Not every day, no.
Most likely you have a high-level programming language, whether it's Java or Ruby or Python, right? And that hides completely all that background layer. Today in quantum, we have to worry about those transistors. Right?
Yeah.
We have to worry about the qubits, how each hardware works and all that. So we're at a very low level still. The second thing is that quantum is not for everything. Quantum is not a universal solution that will replace computers. There are very specific cases, very specific problems, mathematical or computational problems, that quantum is great at. So in the same way that you have today in your computer a CPU and a GPU next to it that does very specific calculations, or a mathematical coprocessor, most likely you will end up having a QPU that takes care of those specific calculations. Maybe an optimization problem, maybe a simulation, maybe driving random numbers. So for the average developer in maybe a decade or so, it will be kind of transparent. And it will be closer to the work that we do in high-performance computer, in HPC, FPGAs, and the likes, but still very relevant for the work that we do in finance, the work that companies in logistics do, in material science, and so on.
What kind of people are working in this field at your company, for example? What is the mixture of professions that you need to actually make this come true?
That's a great question. So traditionally, the answer would have been physicists with a PhD or two. And you need them. You need a lot of them because that's the basic research. But nowadays that we're getting into the integration and the applicability of quantum, we're starting to get people that are more like jack of all trades type of roles. I'm an engineer. So I think more from that applicability perspective. We definitely have mathematicians on board and many software engineers. So now you have to start looking at the whole pipeline together. Take something that the physicists bring from academia, from the research, and how do we make this real? And that's the job of the engineers.
Yeah. And what do you see as a timeline for when basically every company needs to have this knowledge to somehow integrate quantum technologies into their everyday problems?
I think it can take years. Because it's definitely not an easy thing to do. And also learning the domain is fundamental. What we see at Moody's when we work with quantum computing companies is that they're fantastic at the algorithms. at building new solutions,
Yeah.
but they don't know the domain. That's very similar to the data science world, right?
Right.
You can be a fantastic data scientist, but if you don't know the domain, what the data is saying, you're not going to be able to create proper solutions.
Yeah.
So in that sense, quantum is very similar. So you need to bring, like in finance, your quants, all your analysts, all your finance people, you need to bring them into the quantum fold and teach them how this new methodology and technology can help. And I'm really happy that you asked this question, because precisely what we just released today here at QuantumTech is a new solution for finance. We call it a Quantum for Quants and Data Scientists. It's basically a training program that's embedded in our banking learning solutions platform. So any financial institution, or any company really, can upskill their people, their data scientists and quants, either the 3 hours course for everything a business person needs to know about quantum and how it's going to disrupt your company, all the way to how do I start getting deep into this and building my own algorithms and my own applications.
Yeah, this is super interesting that you have this upskilling program, and I'm super interested to understand how the adoption is actually in the industry. Is this perceived as a hype, or are the people actually like flooding your gates and knowing that they need to upskill their people right now because like the next technical revolution is coming?
So the vast majority of players in the financial industry, with some very honorable exceptions that are doing fantastic work and investing a good amount of money. But besides those, the vast majority are not even considering.
Yeah, okay.
And there are two reasons for that. Number one, they think it's indeed hype, as you mentioned. And there's a lot of that. There are certain companies in the quantum industry that maybe exaggerate what you can do today.
Yeah.
As I mentioned at the beginning, there's no quantum advantage today, at least that I've seen or that I could prove scientifically. So the hype is in some extent creating this kind of thing, this quantum winter, similar to what we had in AI,
yes,
right?
Absolutely.
The AI winter, which is something that we want to avoid at all costs. And the second part is that they don't see the problems that quantum can actually solve. So what this tells us is that we need to work from a top-down perspective, from the business side, from the domain. These are the problems that can be disrupted by quantum. This is how you do it. And then finally, we talk about superposition and coherence and interference. You need to talk about that, but that will come afterwards. The ROI for the CEO comes first.
Yeah, I'm a super fan of science fiction, and I'm super happy to live in this age where we actually talk about quantum computers, fusion energy, generative AI. This is everything is so futuristic. And when I was a child, this was all stuff of comics and like futuristic science fiction. Do you see the quantum technologies as like real life magic as I do? Because I personally do not really understand how quantum entanglement works. Or is this like everyday boring average day for you?
So the father or the cousin or the grandfather of quantum, Richard Feynman, he famously said, if you think you understand quantum mechanics, you didn't understand anything. So you're not alone in there. Probably I don't understand it either. Yet it works. I think it's fantastic because quantum mechanics tell us how the world works for real, measured, but it doesn't tell us why.
Yeah.
So that's kind of a bummer. The reality is that it's a fantastic tool, and that's what Feynman envisioned, right? It's a fantastic tool that has the promise to revolutionize how we do computation, how we deal with information. That's the abstract thing overall. So to your first point, when I was younger, I always thought, damn, I was born in the wrong decade.
I know.
Like, too late for the computer revolution and internet, way too early for space exploration.
Yeah,
Maybe that would
same.
be my kids.
Yeah.
But when I got into quantum, I thought, so wrong I was, because we're living an amazing time where we're having this convergence of technologies that by themselves are full industrial revolutions, but now imagine them combined.
Yeah.
We're talking about different horizons here. So you mentioned generative AI. That's fantastic. It's one of my jobs as well, and we do a lot of stuff on that in Moody's. But that's a horizon today.
Yes.
Yesterday, actually. AI has been around for a long time. Quantum is more horizon 2.5, 3.
Yeah.
But at some point, those are going to be linked together. Now, link robotics and nanomaterials and material science and energy like fusion, I think we have a very bright future. Maybe
Yeah.
I'm naive, but I
will see.
prefer to say optimistic.
Yeah, exactly. The same for me. Sergio, thank you so much for your insights. It was a pleasure and have much fun at the conference.
Thank you very much.